Today we're going to be talking about study guide number 20 through 30. And the first thing on the study guide, which is questions 20 through 23, is to talk about the different types of transformations. The first type that it says is what's called a dilation. And if you remember from what we talked about, a dilation is just making an image either larger or smaller by a certain scale factor. So for example, if you have a shape that's like a small triangle, and the next shape, the shape that it makes, is a larger triangle. Okay, this is a dilated triangle. So maybe, for example, this side was had a length of 3, and maybe this side had a length of 9. This is a dilation by a factor of 3 because we multiplied by 3. Okay, the next type on there is a translation. And just like in translating words, where we're just changing the way that it is, maybe from one language to the next language, but we're not changing the word itself. Translation of a shape, all right, is just a slide of the shape. So all we're doing is taking that same shape and we're sliding it. So if we have, say, A, B, and C, A, B, and C, and we just slide that shape, okay, it's just going to slide. It's not going to twist. It's not going to turn. It's not going to get bigger or smaller. But the new A is going to be here, and the new C would be here. So we didn't change the length of anything. We didn't change the size. If this was a 2, then this would be a length of 2. Length of 2, length of 2. If this was a 3, this would be a length of 3. So the size of it did not change at all. All we did is we just moved it in this direction. So that's a translation. It's a slide. The next transformation that we looked at is the rotation. And rotation is just what you think it is. It is rotating a shape. So we talked about you could rotate a shape 90 degrees, 180 degrees, or 90 degrees in the counterclockwise direction. So we have, for a rotation, maybe I have a rectangle here, and I rotate this rectangle. Say if we rotate it 90 degrees, okay, my rectangle is going to look like this. Again, the size of the rectangle does not change at all. The rectangle is just rotated, and it just changes how it's standing. So here it's going straight up and down, and here it's flat. This would be a 90-degree rotation. And this happens to be in the clockwise direction, clockwise. Okay, so we've gone through 3 of them. We talked about dilation, which is just getting larger or smaller. We've talked about translation, which is just sliding a shape, not getting any larger or smaller. Rotation, which is just rotating it or moving it over. Turning it would be an easy way to say rotation. And the last one we have is what's called a reflection. And reflection is just like looking at yourself in a mirror. So there is always something that's called the line of reflection or the line of symmetry. All right, so we have our line of reflection here. And let's say we have our shape. I don't know, maybe it's going to be a smiley face. And we have our smiley face like this. Well, if it's reflected to the other side, it's going to be the exact same distance away from the line, the exact same shape. And the features are also going to get portrayed the same exact way. So I wouldn't have my smiley face going upside down. Okay, it's got to go smiling. That's what makes it a smiley face. So it's going to go the same direction. Okay, so those are our 4 transformations that we have talked about. The next section on your study guide is going to tell if triangles are congruent. So congruent triangles by side, side, side. We have side, angle, side. We have angle, side, angle. and we have angle, angle, side. Okay, there's also the type that is hypotenuse, leg, which is only in right triangles. Okay, so let's take a look at some of these examples. So the first one I'm going to knock out, I'm going to work from the back up to the front. So hypotenuse, leg, congruence in triangles. So let's say that we have a right triangle here, and it says that it's a right triangle, and they are back to back right here. So I know this is given to me. All right, maybe this is example 1. And I'm given this information that they're back to back and that this leg is equal to this leg. Okay, well, all the other information I'm going to add in red. So all the black information will be given to me. All the red information is going to be something that I have to come up with on my own. I know that this side is congruent because they share that side. And I know that they have this angle in common. Okay. I also know that the hypotenuse could be the same, could not be the same. Okay. The only thing I know for certain is that this leg is the same. All right. And they have this side equal, this side equal, this angle equal, this angle equal. So if I'm thinking about doing this, okay, actually kind of tricked you right here. Even though this is a right triangle, it may not necessarily be hypotenuse leg. I lied to you. I'm not going to start with that one. I'm actually going to start with side angle side. Okay, because if we have a side here, an angle here, and then a side, then an angle, and then a side. So this triangle is congruent by side angle side. These two triangles, excuse me. This triangle is congruent to this triangle by side angle side. Okay, another type. Let's look at our second example. So let's look at this. So let's say we're given the following information, and we're asked to prove if these two triangles are equal to one another. So we see that they have a side here and a side here that matches, side here and a side here that matches. Okay, we also know that these two angles are vertical angles. So again, this triangle would also be an example of triangles that are congruent by side angle side. Okay, let's look at a third example, because you're probably thinking, all right, well, what is not side angle side? Are they all going to be side angle side? And the answer is no, and I'm going to show you some different types as we go here. So let's say right here we're given that that side is equal to that side, this side is equal to this side. And this is all the information that we are told. So we're asked to prove, hey, are these two triangles, are they congruent to one another? And what I notice is that they share this third side together. So we have side matches with this side matches with this side, and then obviously the third side they share, all right, which is the same. So these two are congruent by side, side, side. Okay, let's look at fourth one here. So let's look at these two triangles. We have an angle here, an angle here. They share, the top angle is the same, and this distance is the same. And so we're asked to say whether these triangles are congruent or not. Well, what I notice is they have an angle in common, they have a second angle in common, a second angle in common, and then a side in common, and a side in common. So these two triangles are congruent by angle, angle, side. Okay, let's look at a fifth example. I'm going to go back to look at some right triangles here. So these two triangles have a hypotenuse that is equal to one another. And we're asked to prove if they're congruent or not. Okay, so let's see that they share this side. Since that's 90 degrees, this has to be 90 degrees. And so what I notice is they have a side, and an angle. Okay? Well, there is no side-side angle, or it's reverse, going the other way. So what I have to ask myself is, could it possibly be hypotenuse leg? All right, and yes, it is. This is the hypotenuse. This is one of the legs of the right triangle. So these two triangles are congruent by hypotenuse leg. Okay, so those are just some different examples of triangle congruence and how we can prove those triangles congruent to one another just by using the given information that's given to us in the problem, and then justifying some reasons, whether it's the reflexive property where they share that same side, or if we know that, hey, vertical angles are congruent to each other, like we saw in some of those triangles. Okay, let's look at another type of problem. This is going to be very similar to question number 26 on your study guide. So let's look at if we have a triangle that has one of the base of the triangle, or one of the sides of the triangle, is extended to make this angle out here. And let's say that the inside angles, maybe this top angle is 30 degrees, and this bottom angle is 2x plus 10 degrees. And this outside angle, let's just say, is 8x plus 50 degrees. Okay, and what we're asked to do is we're asked to solve for x. Well, if you guys remember, there is a theorem out there. It's called the exterior angle theorem. And so the exterior angle, or this angle here on the outside, is equal to the sum of the other two angles inside the triangle that are not connected to that extended side. So for this case, the way that we would solve this would be to say that angle 1, which is 30, plus angle 2 is equal to angle 3 right here. So we would say that 30 plus 2x plus 10 is equal to 8x plus 50. And so we have to combine our like terms. 30 and 10 would give me 40 plus 2x equals 8x plus 50. Okay, if I subtract 40 from both sides, I get 2x equals 8x plus 10. Subtract 8 from both sides, 8x, excuse me. So I get negative 6x equals 10. And then we're going to divide by negative 6. And you get that x is equal to 10 over negative 6, which is going to be a negative 5 over 3. Okay, and most of the time these are going to not turn into fractions when we work them out. I'm just showing you kind of a more advanced problem, where it's possible to get a fraction. But the main gist of this is to take these two angles and set them equal to the angle that's on the exterior, the angle on the outside. If we also wanted to know, let's say someone came back and asked, all right, well, what is y going to be equal to in this triangle? Well, that would be pretty simple. We could plug 5 over 3 in for our x right here. So 2 times 5 over 3 plus 10. All right, add that to 30. And we know that all three angles inside a triangle are going to add up to equal 180 degrees. But I'm going to draw a cleaner triangle just so that it makes a little bit more sense, easier to see, and see if we can figure this one out just in general. Maybe especially if x is an easy number to figure out. So let's say that this is 30 degrees. Let's say this side is 2x degrees, and let's say the top side is, I don't know, 4x degrees. Okay. Well, we've talked about the angles inside a triangle all add to equal 180. So 4x plus 2x plus 30 is going to all add together to give me my 180 degrees total. Okay, so this is a 6x plus 30 equals 180. Okay, and here we would subtract 30. Subtract 30, we get 6x is equal to 150. And then we would divide by 6. So 150 divided by 6. So it's going to give us 25. X equals 25. Okay. Now for mid-segments in a triangle, last thing, mid-segments in a triangle. We know that the mid-segment is formed by connecting the midpoints of two sides in the triangle. And so this mid-segment right here in the middle is half of the side that it is parallel to. So for example, if this side is 20, the long side, then this short side is 10. If it is, let's talk about some other numbers that we could get. Let's say if this long side maybe is 3x and this side is, I don't know, 10. Okay, you know the short side is half, so the long side has got to be 2 times that. So 20 has got to be equal to 3x. Okay, maybe it'd be simpler if this was a 2x. So 20 is equal to 2x, and that's going to be a simpler problem for us to do. Obviously, you divide by 2, and you get that x is equal to 10. Okay, maybe we had another type. Maybe this was, I don't know, I'm going to do this in blue. Maybe this is 12, and the bottom is 4x. Okay, so this whole thing on the bottom is 12 times 2. So 12 times 2 is 24. So you have 4x is equal to 24, which means that x is equal to 6 in this case. And so that's going to get you through the mid-segments of triangles. Moving on to number 30 deals with parallelograms and the missing value in parallelograms. And that's going to be covered in tomorrow's video. So I think that that's all we have for today. So good job, good luck on your study guide and the rest of your problems.